All right, ready to dive into something kind of mind-bending? We're talking machine unlearning today.
Ooh, yeah, it sounds like sci-fi, doesn't it?
It really does. It's basically like hitting delete on specific things an AI's learned.
Without having to retrain the whole system, right?
Exactly, like surgically removing that embarrassing memory except for an AI this time.
Not just about awkward AI memories, though.
True. Why is this becoming so important then?
Well, for things like data privacy and security, right? You should be able to remove your data from a model.
Yeah, it makes sense, like a right to be forgotten, but for AI.
Exactly.
But today we're going even deeper into multimodal unlearning, AI that learns from both text and e-images.
Which makes hitting that delete button a whole lot harder, that's for sure.
Way trickier. And that's where our source material comes in a research paper about CLEAR.
Ah, yes, CLEAR.
Yeah.
A new benchmark for testing multimodal unlearning, or MMU for short.
CLEAR, love it. So what's the big deal about this benchmark?
Well, they use a domain that's easy to grasp. Fictional authors and their photos.
Okay, so it's relatable, helps us understand this complex topic.
Right, and AI learns all about these made-up authors, names, style, what they look like.
Then we ask it to forget certain authors,
Mm,
like a literary memory wipe.
exactly. But, of course, it's way more nuanced than that.
So that's where CLEAR comes in, to test if the AI really forgot.
Yes.
Yeah.
It's not like we can just ask, hey, AI, remember this guy?
Right, Needs to be more rigorous than that.
So they have these clever evaluation sets to test different things.
Like what? Give me an example.
One set has authors the AI should forget. Another has those it should retain.
So unlearning is targeted, doesn't just wipe out everything.
Exactly. Got to make sure it doesn't throw the baby out with the bathwater.
I like that analogy. What else do these evaluation sets look at?
They want to make sure unlearning doesn't have side effects,
Oh, right, like making sure it doesn't break the AI completely.
Yeah, so they use sets with real celebrity faces and general visual questions.
So it's like after forgetting a fake author, can it still recognize Elon Musk?
Precisely. And can it still understand images in general, that sort of thing?
Okay, makes sense. Got to test the whole system.
It's about making sure the AI hasn't become unintelligent in the process.
But how do they actually measure if the MMU is working? Is there an AI lie detector?
Not quite a lie detector, but they have a few cool metrics.
Ooh, I love metrics. Hit me with them.
One is called RUGI-L, measures how well the AI's answers align with the correct ones.
So after unlearning, is it avoiding mentioning the forgotten author?
Exactly.
Right.
Even indirectly, it's looking for those subtle clues.
Clever. But couldn't an AI still secretly know something, even if it gives the right answer?
That's where the probability score comes in, how confident the AI is.
So even if it hides its knowledge, its uncertainty is a giveaway.
You got it. They're trying to peek into the AI's mind, see if it's truly forgetting.
I like it. Any other metrics in their arsenal?
They also use the truth ratio. It compares the likelihood of the correct answer.
To the likelihood of similar BUT wrong ones? Like, is it really forgetting or just confused?
Precisely. It's like, okay, AI, are you genuinely forgetting or just playing dumb?
This CLEAR benchmark is impressive, like a carefully designed experiment.
It really is. It's seeing if you can make an AI forget without messing up its smarts.
Now that we get how CLEAR works, let's talk about the challenge itself, multimodal unlearning.
Right. Here's where it gets even more interesting.
Why ISMMU is so much trickier than making AI forget some text.
Well, MMU is a super young field. That's a big part of it.
So we're in the wild west of MMU research. Makes sense why we need benchmarks like CLEAR.
Exactly. Got to have standardized ways to test and compare these unlearning techniques.
Before we jump into the techniques themselves, can we get a quick primer on these MLLMs?
Multimodal large language models, you mean? Sure. Good idea.
It's one thing to unlearn text, but images. How do you even start?
To grasp the challenges, it helps to understand how an MLLM works, under the hood.
Okay, break it down for us.
They have three main parts. First, the modality encoder. Think of it like a translator.
Translating what exactly?
Raw data, like text or images, into numbers the AI can understand.
Okay, so human language to AI language. What's the second part?
The projection layer, crucial for multimodal learning. It's like a universal translator.
Meaning?
It lets the numbers from different modalities like text and images understand each other.
So finding a common language for text and images to have a conversation.
Exactly. In the AI's brain, so to speak.
What's the third part of this AI dream team?
The pre-trained language model. The brain, you could say.
So it's already been trained on tons of data, right? Learn general skills.
Yes. And in an MLLM, it gets this blend of text and image info thanks to the first two parts.
Got it. The translator, the synchronizer, and the brain. But how does this make unlearning harder?
Well, the research found that trying to unlearn in just one modality, like text only,
Uh-oh, I have a bad feeling about this.
can lead to catastrophic forgetting in the other modality, the images in this case.
So you make the AI forget an author's name, and it also forgets their face.
That's the risk. And it gets even trickier, believe it or not.
Lay it on me. What else did they find?
Another issue is that many unlearning techniques, while good at making the AI forget,
Yeah.
can actually hurt its performance on its original tasks.
Oh no, it's like erasing a bad memory, but accidentally deleting all your happy ones too.
A terrible trade-offs.
Yeah.
The challenge is to make it forget without losing its overall intelligence.
Right, it's a delicate balance.
Exactly. Unlearning and retaining the useful stuff.
Okay, so MMU is challenging. We have to be careful. How are researchers tackling this? What approaches are they exploring?
The paper looks at a bunch of techniques, but instead of listing all 14,
Yeah, that would be overwhelming.
let's group them into categories based on their approach.
Ooh, love a good categorization system. Maybe give them fun names too. I'm feeling creative today.
Why not? Let's start with a more direct approach. It's almost like forcefully deleting info.
Okay, forceful. I like it. What should we call those?
How about brute force forgetters? This includes retain fine-tuning, gradient ascent, and gradient difference.
Brute force forgetters. It's got a ring to it. These sound like the risky ones.
You got it. They can lead to that catastrophic forgetting we were talking about.
Making the AI forget the author, but also damaging its broader understanding.
Exactly. Sometimes it just lose too much knowledge overall.
Yikes, that's not good. What's next? Are there any techniques that are a bit more, I don't know, gentle?
There are. They're a bit more strategic, you could say.
Strategic, instead of just nuking the info.
Right, more like nudging the AI's outputs in the right direction.
Okay, I'm intrigued. What kind of techniques are we talking about here?
Things like KL minimization, IDK tuning, and preference optimization.
Those are some interesting names. What's the overall strategy here?
Instead of deleting info, they try to tweak how the AI responds.
Ah, so it still remembers stuff, but it's learned to keep it to itself.
In a way, yes. It's more about controlling what the AI expresses.
So less risk of that catastrophic forgetting then.
They do tend to be a bit gentler on the AI's overall knowledge.
That's good. We don't want to break the AI in the process of making it forget.
Right. The paper has a lot of detail on each technique, if you're curious.
Maybe we can link to it in the show notes for our listeners.
Good idea. But for now, let's move on, shall we?
Absolutely. What's the next category? Hit me with another awesome name.
All right, so this one gets a bit more complex.
Woo! I love complex. Bring it on.
It involves training multiple AIs and having them, well, interact.
Multiple AIs. Now we're talking, what do they do? Have AI therapy session.
Not quite, but it is about communication between AIs.
Okay, you've got to give me the category name. I'm on the edge of my seat.
Let's call these the teacher-student frenemies.
Teacher-student frenemies. Okay, now I need to hear how this works.
So you have one AI, the teacher, that's learned all the info, including the stuff we want, gone.
Makes sense. The teacher knows it all.
Then you have another AI, the student. The goal is to train the student to disagree with the teacher.
Disagree on purpose.
Specifically about the info we want unlearned.
So it's like, teacher says this author is great, but student's like, nah, never heard of him.
That's a great way to put it. The student learns to not do what the teacher says. Selectively, of course.
Wow, that's seriously clever. Okay, what about the last category? Are we done with the AI surprises?
One more up our sleeve. This one's about manipulating the AI's internal representations.
Internal representations, like messing with its memory storage.
Exactly. Think of it as tweaking how the AI stores memories, not just what it remembers.
Ooh, getting into the AI's subconscious. What are these sneaky techniques called?
Let's call them the sneaky ones for obvious reasons. This includes things like LMMU and RMU.
The sneaky ones? Perfect. So these are like undercover agents changing the AI's memories from within.
You got it. They're a bit harder to explain simply, but they offer cool possibilities.
All right, so we've got our 4 categories. Brute force forgetters, subtle mind benders, teacher-student frenemies, and the sneaky ones. Quite the lineup. Is there a clear winner in this MMU battle royale?
That's the question, isn't it? But unfortunately, it's complicated.
Of course it is. This is AI we're talking about. Nothing is ever simple.
Right. Each technique has pros and cons. The best one depends on the task, what you're trying to do.
No magic bullet, I guess. But surely some approaches are more promising than others. What stood out in the paper?
One of the coolest findings was about LoRA regularization.
LoRA regularization, that's a mouthful.
It is, but it's a simple idea with big implications for MMU.
Okay, I'm listening. Break it down for me. What is LoRA all about?
So LoRA stands for low-rank adaptation. It's a way to fine-tune huge AI models efficiently.
Efficiently. Meaning?
Instead of retraining the whole massive model, you add this small separate module.
Ooh, like a little brain implant for the AI. But how does this help with unlearning?
Here's the trick. During unlearning, they penalize the AI if its LoRA weights get too big.
Penalize? Like giving it a timeout for bad behavior?
Kind of. It keeps the AI closer to its original state, preventing it from straying too far.
Ah, so it's like a leash, preventing it from going crazy and forgetting too much.
A great analogy.
Yeah.
And the best part, it actually works.
It does. Spill the tea.
LoRA regularization significantly reduced catastrophic forgetting for a lot of the techniques.
Wow, that's huge. So this LoRA thing is like an MMU enhancer.
You could say that.
Yeah.
It's not perfect. It didn't work for all the techniques, but it's a promising step.
I'm loving all these aha moments. I feel like I'm actually getting this MMU thing now.
It is fascinating stuff, isn't it? Figuring out how to control what these powerful models remember and forget.
It really is. Speaking of control, let's shift gears a bit. We've talked tech, but what does this mean for our listeners?
Ah, yes, the so what question. Why should anyone care about making AI forget?
Exactly. It's cool science, but how does it impact the real world?
Well, MMU could address some of the biggest concerns we have about AI. You know, the scary stuff.
Like what? Give me the worst case scenarios.
Take privacy, for example. Imagine being able to completely remove your data from any AI system it's trained on.
Wow, that would be amazing. With all the data out there, having a real delete button for AI.
Right. That's the kind of control MMU could give us.
What else? What other AI nightmares could MMU solve?
Security is another big one. Think of AI in finance or healthcare, sensitive stuff.
High stakes. What could go wrong there?
What if someone tries to mess with the AI? Feed it bad data to make it do bad things.
Ooh, like poisoning its mind.
Exactly. MMU could help unlearn that harmful info, protect the AI from being corrupted.
So it's like an immune system for AI fighting off bad data infections.
Precisely. It's about making sure AI is used responsibly, that it's learning the right things.
This is why this research is so exciting. It feels like a new era of AI where we have more control.
I agree. But as with any powerful tool, there are questions, ethical questions.
Oh, here we go. The philosophical part of the deep dive.
Just because we can make AI forget, should we always do it?
Ooh, that's a good one. What kind of dilemmas are we talking about?
Think about accountability. If an AI messes up and we just make it unlearn the bad info.
Are we letting the creators off the hook?
Exactly. It's like erasing evidence, even if the crime was a bad AI decision.
Right, and who decides what gets unlearned? What if it's used to cover up wrongdoing?
Or if companies use it to forget things that make them look bad. Lots of potential for misuse.
MMU is a double-edged sword. We need to be careful. It's not just about the tech itself.
You're getting it. It's about our values, our ethics, how we want AI to exist in the world.
This has been mind-blowing. We've gone from AI memory wipes to the ethics of forgetting. Any final thoughts for our listeners before we wrap up?
It really makes you think, doesn't it?
Yeah.
About what it would mean for an AI to remember absolutely everything.
Yeah, it's kind of creepy, to be honest. We humans forget stuff all the time. It's part of who we are.
Right. It's natural. But perfect AI memory, that opens a whole can of worms.
You mentioned privacy earlier. How does that play into this whole AI remembering everything thing?
Imagine, what if an AI could remember every online interaction you've ever had?
Oh no, not my cringy teenage forum posts.
Uh-huh. Exactly. Every purchase, every search, a complete record of your digital life.
Even if it's used for good, that's a lot of power. Could be misused so easily.
And what about the right to be forgotten? Can you demand an AI erase your past if it has it stored?
It's like your digital shadow becomes permanent, even if you've moved on.
And then there's history. We talked about how it's always being rewritten.
Right. Perspectives change, new info comes to light, sometimes things are intentionally left out.
Now imagine an AI that remembers everything perfectly. Every event, every conversation, every decision.
Whoa, that changes everything. Whose version of history becomes the truth then?
Exactly. If AI becomes the ultimate history book, we need to be so careful about bias.
It's like having a perfect time machine, but who controls it? Who gets to decide what we remember?
And do we want to remember everything? Is perfect memory even a good thing?
You know, the more we talk about this, the less sure I am. Maybe some things are best left forgotten.
That's the heart of the ethical dilemma. It's bigger than just MMU.
Right. It's about all powerful AI, what they learn, what they hold on to.
As we build these systems, we have to think about the implications of their memories
It's not just about making them smart, it's about shaping how they interact with the world, with us.
and what kind of future we're creating. One where everything is remembered or one where we allow for forgetting.
Wow, this has been eye-opening. We started with making AI forget, and now we're questioning whether remembering everything is even desirable.
It's a journey, isn't it? And we're all figuring it out as we go.
Any final thoughts for our listeners as we wrap up this deep dive into multimodal unlearning?
I think the biggest takeaway is this. We're not just watching AI happen anymore.
We're not passive bystanders, right?
Exactly. We have a voice, a responsibility to shape these technologies.
To make sure they're used ethically, that they benefit humanity, not just serve some corporate interest.
It's a powerful moment, and we need to make our voices heard.
The future of AI is in our hands. Let's make it a future we can be proud of.
Well said.
That's all the time we have for today. Thanks for joining us on the deep dive. Keep exploring, keep questioning, and keep learning.